Good morning. Welcome back. Today, this is Cody Henriksen. I'm going to talk about MariaDB and how we can use the data control language subset of SQL, or my favorite, Squirrel, so we can address some of the concepts that are a little bit beyond the regular intro level. We want to see some of the ways we can actually manipulate the structure of who has access to the database. Let's go ahead and take a look. Like I said just a second ago, the main question we're talking about when we're talking about the DCL subset is who gets access. Where are we going to provide access to individuals when they have a login to the database? Because we don't just let everyone log in willy-nilly. That's not how it works. So this is what we're trying to answer within the DCL subset. We have both a positive and a negative connotation that we can use with this. We can either give information or we can take it away. I know. Most often, though, this is the decision of a management level employee. This is not something that a regular database employees we working with, definitely not intro level, but it's the idea that we want to see what is going on with this so we can understand, as especially a beginning developer and working with databases themselves, we understand how the actual structure works and what's involved with that. There are three things I want to talk about when we're working within this, and the idea of the structure, security, and access. Because structure is the actual database itself, talking about the tables, the things we have access to, the fields, the columns, etc. What's going on inside that? Security. Where do we provide that level of security? Are there password restrictions? Are there specific types of passwords? Are we actually trying to prevent, hacking and stuff on this? And then on the third level, what is about access? Where do we have access to this database? Who has access to it? Because we can do some configuration stuff in there, and we'll take a look at that as we actually go through these statements. When we're talking about DCL, we're really talking about who is involved in the database. We have two different types of categories to work with. We have the idea of roles and the idea of users. The first one, the most one we'll start off with, is the idea of a role. It's a collective permission group, and it's really the best idea to start with a role first and then work your way down. We want to have the idea of a top-level design on this because we want to make sure we set it up so it's strong and stable at the beginning, and then we can add features and functionality as we go along. Just like when we're doing regular programming, we wanted that same approach when we're working with the database access. Now, like I said earlier, this is very useful for the business and the high-level project level thing. On the introduction and academic side, this role level thing is not really that very important, but it's something you really will use when you're talking about the actual use of a database. Also with roles, we have the idea that we can have multiple memberships. So you can have a membership in this group, and this group over here. And one of the really powerful, annoying, I'm not sure how the best way to say this, is you can have conflicts between the access levels, a member of this group, and this group that I have has a higher level, and this group has a lower level, and that can be a problem for what you're doing. So you have to make sure when you're using that multiple membership approach that you correctly log in and use your membership approach to actually have the correct level of access, so you don't cause yourself problems as you go through that. On the user side, on the other hand, we have the individual level access. This is how we talk to people who are logging into our database. So this has a password. Now this password has specifications. You can make this be redonkulously simple, or it can be more complex and have some security built into it. We also have the ability to specify users at a level of different access. We have an IP level, a host level. We have some great way that we can differentiate between the users so we can actually see what level we're working at, so we can have different usernames and logins and talk about that. So the first thing we have inside our DCL subset is the create statement. Wait, create, that's part of the DDL. We're defining, we're making things, but when we're talking create, we're also talking about how we can create roles and users. Like I said earlier, it's a really big top-down design thing. We want to design our roles first, our users afterward, because we really want to make sure that when we're talking about a database and we're talking about the stability and the structure and the integrity of the data itself, we really want to make sure we have that design first and then we implement. And so that's where roles first. The host matters. When we're talking about working within the system, we want to make sure we talk about who we have access to, because we don't want to just grant all access all the time, especially when we're talking about major level access, because when you grant that access to just any IP address, you're making it so your database is fundamentally open and therefore flawed. So we want to make sure we take that away and make sure we design that explicitly. You can also specify some password restrictions, and that's something you can really do to have some management of how to make your database be a little bit more secure. So we have our create syntax right here. Over here on the left, we have the actual, just the structure of the syntax. On the right, we have an example. So let's talk about this really quick. So for when we're making a role, it's just simply create role and then role name. Really quite simple. When we're talking about create a user, we have the option to create the user. We have the is not exists option that we can potentially put that inside there, followed by the username. We then be identified, and that's where our password. So I honestly think we should always identify by a password, whether we do this explicitly using a plugin so we can have secure features or not. But you definitely want to identify the password. You don't want to just simply create a user randomly. You then have some limitations you can place on it, and then the password options you can place on it. And again, order matters. So create the user, identified, then limitations, and password options. Over here on the right, we can see that we're creating the role administrati. We're creating the role CS teachers. We're creating a user then, Lady Ada Lovelace at %. The at % means that Lady Ada Lovelace can log in from everywhere. She's got the power. I know, Lady Ada Lovelace is cool. Lady Ada Lovelace has then identified the ultra secure password. I know, it's amazing. And then she can only have, however, 47 queries per hour because, well, I'm just being silly and demonstrating the access for this. Now, the interval 45 days password expiration, that's saying, hey, this is how often this user is going to have to change their password. And so we have that right there. We then have another user created. We're having Alan Turn at localhost, who's identified by dead password, comma Alan Turn at %, identified by secure password. So even though I have two different things right here, these are basically two separate users. One's for localhost only, one is however logging at anywhere in the spot, and they have different passwords. And their password is set to expire, which means as soon as they log in, they have to change their password. Now, with the options that are created right there with the max queries and the password expire, those are global level accesses that belong to all the users that are created inside that statement. And so that password expire affects both the at localhost and the at %. So those are things that happen for both of the Alan Turing logins. Same thing with the if I had another user on the Lady Ada Lovelace creation statement, that password expire interval would apply to all the users created within that same statement. So that's what we're looking for with that when we're talking about how to create a user versus creating a role. As you can see, creating a role, it's cake. We're good to go. Then we want to talk about the privileges. When we're talking about privileges inside a database, we have a couple different structures of privileges we have to address. We have our system level privileges and we have our object level privileges. Now, when we're talking about this is for our next piece, we have to see what we want to have access to. So we can create, drop, or alter. On the object level, we have insert, select, update, and execute. And we've talked about those basic uses in some of our other videos when we're talking about how to actually use a database, but that's what we have when we're granting privileges. So there's a group into those two different types of categories. And so what are we going to give them access to when we're actually working with that? And so we use those privileges when we're talking about the grant statement. And so we add that specified permission or permissions, plural, separated by commas, of course, to the role or user. And again, who do we do this to? We give them to the role because, again, we want the better stable database structure. These are grouped, of course, by the subset, like I just said, and you can apply these on a user or role level, but again, where do we grant them? We grant them to the role. It really makes sense to give our roles access rather than giving the grant access to the user because we want to make sure that we have that same structure and stability across all of our stuff. You want to make sure you grant the least access required at the most common level and then use those roles to provide that best management. And this would be going on to more of a data management course or database management system where you're actually looking at who do we need to give this access to? Again, this is again, top level design. You're planning out and looking at your actual database as a logical physical structure and seeing, these people and those mammals need access to this structure. Let's grant that to those groups, but not give it to this group over here who has no access to it or needed. So we want to make sure we design that and work with that explicitly. And so that's where the grant idea comes into play. To see the syntax for a grant, we have the idea that we're granting a privilege on some object to a role, or we're granting a role to a user. And so I have a couple different demos of this over here on the right. So we're granting administrati to Alan Turing at %. So he is, Alan Turing is a administrator. I'm going to grant Ms. Romchik the CS teacher's role. And then we're going to grant select on everything, absolutely everything, start asterisk, to get CS teacher. So Ms. Romchik can access everything inside there. She can read all the data. I'm going to grant her alter, the alter privilege, so administrati can change everything, the structure of the MangoFruit database. They can change anything they want. I'm going to grant insert on MangoFruit.products, only the insert privilege to CS teachers. So anyone in the CS teachers group has the ability to insert to that database. I'm going to grant drop on MangoFruit.cells to administrati. Now, they already have alter, but they can also totally just drop that entire subtable. So that's where we have that ability. They can drop everything inside that. So we can see how the syntax itself works so they can create those access, so that the users that are members of those roles can have that access to those components of the database. And so those accesses that we provide are specified via the grant privilege. Now, like I said, we can also go on the complete opposite side and we can revoke access. Yes. So when we're revoking access, we're going to take away permission from some specific component. And so if you revoke a permission from a user or role in conflict results, they always get the lowest possible result. So make sure you plan this out. Again, that top level design is a key part when we're talking about database management. So you can apply this to individual levels or for everybody. You can actually revoke everything. And again, just like all, you want to plan before use because when revoking, you're totally removing access to things. So we have our syntax, which is very similar to what we saw for the grant syntax. When we're talking about revoke, we're going to revoke some privilege on a structure from a user or a role. We can also revoke a role from a user. So revoke select on magrafruit.asterisk from anonymous student at any access. Or unrevoke CS teachers from a hacked account. So I can take my revoking and I can do specific things from things. And so if, say, for example, we identify a break inside our system, we can identify that user that's involved with that and simply revoke access to that user, or we can go and revoke specific components from specific groups inside that. So we can have the ability to take that out and make that manipulation on the access levels using the revoke statement. Now, when do we want to do this? We're using the DCL statement, like I said, for management level access, because this is when we're talking about who is going to be talking about this on the big, broad scale of this database. When you're talking about database projects, beginning database classes like this, what we're working with right now, we're not going to really be working with the DCL subset at all, but it's a good time to practice and see how to actually use this to see what's involved with actually using this. And if you continue on working with databases, especially working with groups and working with structures, that's when you want to make sure that you have all the roles and stuff specified properly so that your design of your database has the correct approach. Now, this is not something you'd ever be done on an entry-level worker system. So if you're getting hired at a company to work on database, even a database engineer, you're probably not going to be granting a lot of role access level stuff because at your level, you're only be working with maybe some structural design and possibly granting just other user accesses to people within your department. So this is something that, like I said, this is not a entry-level component, but it's something we definitely want to address and introduce because the concept itself is important to know. And you can also look at the errors you're reading when you get this. So if you try and actually run something, the errors that you receive can sometimes tell you why your permission errors are set where they are. So you can figure out, oh, you don't have permission to do this. So that means I have to actually maybe talk to my database administration person above me so I can figure out what I need to do so I can have access to that resource properly. So that's again, the purpose that we're doing for this for. Now, I know I've been using command line for a lot of all this stuff, but we also want to take a look at the MariaDB permissions page for this because you can see all the amazing features of doing this using a GUI plugin right here. So you can access all the different components by looking at the different structures right here, and instead of having a syntax to actually do this, all you have to do is put the correct checkbox on the right user and say go, and you're good to go. You can see that also in the way that the administration is set up, that it's grouped by the language type. So you have the data access for the DML languages, the structure type for the DDL, and the administration access for the DCL subsets. And so even within the actual DCL access, it uses the same 3 subsets of databases, so you can actually control and work within that. And so that's a quick little introduction to the DCL subset. Thanks again, and have a great day. Bye.